Here we are at example 1 from our 4.3 number 4 set of notes. Now when we're looking at these, we're factoring trinomials, and specifically now a is no longer necessarily 1, it's going to be a prime number, okay? Now the game starts to change up a little bit, but not dramatically with how we saw 4.3 number 3 set of notes, okay? Now when we look at the steps, you're still going to try and do your GCF, always. Anytime you're factoring, always start off with a GCF. Then you're going to create a list based upon your A and C value, just like what we were doing for our 4.3 number 3 notes. Now, when we look at example 1, we're asked to factor each completely. You have an A value of 2 and a C value of 18. What we're going to go ahead and do is multiply those two values together. So 2 times 18. That gives us 36. And then you're going to create a list from those numbers, that product. So a list of 36. In this case, you end up with 1 and 36. You have 2 and 18. You have 3 and 12. You have 4 and 9. And 6 and 6. Now, the reason why the 4.3 notes and the prior ones, we didn't really stress this as much because this value here was always 1. And so that's why we really kind of mostly just looked at the C value. But now that you have an A term right here, other than 1, the game changes. You do have to take the product of your A and C, okay? You have to do that. Now, just like before, we're looking and we're seeing which of these pair right here combine to give us positive 13 in the middle. Well, 4 and 9 accomplish that. And so as a result, those are the values we're going to use. So we have 4p and 9p. And again, they both have to be positive to be able to give us this positive 13p that we want in the middle. All the other numbers we're going to go ahead and drop down. So we have 2p squared and our 18. They just drop down. Okay. The 4p and the 9p doesn't matter which order they're in. Okay. Now, what we're going to go ahead and do, factor these by grouping, so we're just going to split it down the middle. And then looking at the first pair, we notice that we can pull a 2p out of both of these. And what we're left then with would be a p plus 2 when you factor those out. The second pair, we notice that they both share 9 that we could pull out, and that's it. So you can factor out a 9, and then you're left with p plus 2. And that 9 was positive that we pulled out. So then lastly, since they both share this common factor of p plus 2, you have that factor p plus 2, and then times the leftover stuff, 2p plus 9, coming from here and here. So this is our factored form. Again, though, that is example 1 from our 4.3 number 4 set of notes.